Hey team, Andre from High Performance Academy here. Welcome along to another one of our webinars. Today we're going to be diving into the auto tune and, for that matter, the closed loop fuel control functionality around the ECU Master EMU Black. I've obviously got that fitted to our version 11 Subaru STI, which I am currently sitting in. Just to bring you up to speed with what's been going on over the last couple of weeks, we are still running one of our most exciting giveaways yet, which is for a Haltech Nexus R5, which is a relatively recent release from Haltech. I don't have it sitting here in front of me, but don't worry, I'll show you how you can find out a lot more about that in just a few moments. The Nexus is something we previewed back in PRI 2019 now, back when the world was still allowed to travel, and it wasn't quite available for public consumption back then, but last year Haltech got that out the door. The exciting thing about the Nexus is it is a relatively unique product in that it combines a fully functioned ECU, and it is a pretty advanced ECU at that, basically an all new platform from Haltech with brand new tuning software, but it also combines a power distribution unit, power management unit, depending what you want to call that. So basically that is solid state control of your power supply to all of your different circuits around the car. Now, that's not just necessarily for operating your engine. You can use that power distribution module for basically controlling the power distribution for all of the circuits in the car. On top of this, it's got some of those normal features that you would expect in any current crop of ECU, such as the ability to have onboard logging, and it is high-speed onboard logging as well, up to 1 kilohertz, which is relatively rare, and that high-speed logging is quite important for some of the more advanced functionality that we are seeing incorporated, particularly in a motorsport ECU. Also, again, not particularly unusual here, but onboard oscilloscope, which the Haltech Elite didn't have. So we are combining that Haltech Nexus R5 along with our suite of tuning courses, and if we head over to my laptop screen, I'll get the team to chuck a link into the comments that you can follow, but this is where you will come. Total package value there, $5,000. Do not miss out on this giveaway. It does not matter where in the world you are joining us from. We will ship it free of charge to your door. There are currently 9 days left for this giveaway, so you do not want to miss out. There are also a few other tasks that you can complete. Once you get started, that will give you a few more entries into that draw. So I'll get the team to chuck a link into the comments that you can follow that will get you to that point. Now, for those who have been following us for a while, you will remember the saga of our SR86 endurance car. This is our Toyota GT86 powered by a Nissan SR20 VE. We attempted a fairly ambitious engine swap last year where we tried to put our SR20 VE that was previously built for a Nissan 350Z into the car and get it up and running in a touch over 4 weeks before the start of the endurance series, because we did have a massive delay on the new V8 that was being built for it. Anyway, again, for those who have been following, you can check that saga on our YouTube channel. We basically followed the build on that. It didn't really go to plan. We had a number of reliability problems. We decided to pull the pin about halfway through the endurance series late last year and regroup, refocus, and sort through all of the issues that had cropped up so that we could address them properly and we weren't going to have continued problems. It has been a long road, but we have got that back on track. And again, I did mention that we had that up and running. And if we can head across to my laptop screen, I have already shown this, but just to basically bring us up to speed, this is where we ended up. So the red line here on the dyno graph, this is our old existing engine with the old Calford cams in it. Made great power, absolutely not unhappy with the power. This was only at 15 psi of boost, 1 bar of boost, and we're already at over 500 wheel horsepower. The problem with it was that it really wanted to be all the way out here. That run there is out to 8,700 RPM, and it's only just starting to flatten off in terms of the power. And that was one of the issues we highlighted with our reliability, particularly with a 6-speed sequential gearbox, very close ratios. Out on the track, we were essentially spending 90% of the lap between about 7,000 and 9,000 RPM. not really ideal, particularly for something that was designed around endurance racing, and it wasn't what we wanted to achieve. The engine was already making more power for the boost than we had expected. So one of the aims over the last few months was to get that power band across to the left a little bit. So we switched to a set of factory P12 cams. So that's what we've got shown here, the blue line, and we can see particularly between sort of 4 and 5,500 RPM just how much more bottom end the P12 Primera cams have given us. That being said, not a huge sacrifice right here at the top end either. So we're down around about 10 odd horsepower at the same boost pressure. Unfortunately, the boost pressure on the red run wasn't actually being logged to the dyno. So you can see down the bottom here, we've got our manifold pressure being logged in on our blue run. So it was all looking pretty promising. It's still actually going up at 7,600, and the torque has only just started to plateau there. So chances are it still actually wants to rev to maybe 8,500 RPM, but we capped it there anyway, learning from what we'd already found. So we had a round of our sprint series at Highlands Motorsport Park, our local racetrack, coming up, which we're pretty stoked about, pretty excited to get the car back out on the track, shake it down and put it through its paces and see basically what else was going to break. We probably weren't heading into it with massive expectations, but pretty excited anyway. I got a little less excited, however, when I saw the weather forecast, because it was forecast for essentially torrential rain, particularly on the Saturday of the two-day competition. I wasn't too stoked about heading to the track with a car that on its minimum boost setting essentially was making 460 wheel horsepower. Basically a completely new car that I'd had very little racetrack experience with on a wet track. So we sort of scrambled around a little bit to see what we could do to get that power down. So if we go to the next slide here. So what I did was I swapped from a 1-bar spring, a 15 psi spring in the Turbo Smart wastegate, which limits the minimum boost pressure we can run. Swap that down to a 10 psi. Due to a bit of a compromise in the way the wastegate comes off the manifold, we did still end up with our boost creeping up. So basically the green run here, 401, let's call it 402 wheel horsepower, that was with the minimum wastegate spring pressure. And we ended up basically with the boost pressure starting down here, around about 7 to 8 psi, and basically the boost sort of crept up as we went through the run. We're getting up to about 12 to 13 psi by the time we got to 7,500 RPM. So that's why we've got that that power is still relatively high. Now, not really a lot I could do with that. However, this is where some of the electronics that we have at our disposal can be advantageous, and there's ways that we can get around this. So already I've got a multi-position switch on the steering wheel, and I had been using that for driver boost targets. Now, obviously, I can't go down below, in this case, 12 psi or thereabouts at 7,500 RPM. So that sort of limits me. You can go between 460 horsepower at 15 psi and 400 horsepower at 12 psi, and that's not probably enough for a completely wet track. So I just want to talk you through some of the changes I made in the Motec M1. So for a start, what we'll do is we'll actually go out of this and we'll come back to our tuning workbook here, and we'll come over to our boost control, which is where we are here, and I'll just talk you through how this system works. So for a start, if we don't want to do that one, we want to come down to our boost aim table. So what we've got here is a three-dimensional table, and this is quite important. This is something people overlook. What I've got here is throttle position on the vertical axis, and we've got engine RPM on the horizontal axis. The numbers in this table are our gauge boost pressure, so 100 kPa, as we can see here, as our target at wide open throttle. That's actually 100 kPa gauge pressure, so 100 kPa above atmospheric pressure. In round terms, basically 1 bar of positive boost. What we can see though is that as we reduce the throttle down here, I'm also reducing the boost targets, and this is something that's really easy to overlook. The problem is that turbochargers are really good at making boost pressure. So particularly if we're above the boost threshold, let's say 4.5, 5,500 RPM, we're at wide open throttle, we're going to get 1 bar of boost. However, we can generally pull the throttle all the way back to maybe 40 or 50%, and we're probably still going to end up with pretty close to 1 bar of boost. Basically, the wastegate closes to drive the turbocharger harder. That's how the system works. And we still end up with relatively similar boost. We will be down a little bit in power, but probably not the sort of power or torque reduction that we'd expect at half throttle. So that's where targeting our boost relative to our throttle position can really tame down a turbocharged car and make the relationship between engine torque and throttle position much more linear. The driver can then understand that it's much easier to control the car, particularly if you've got a high powered car with limited traction, particularly on a wet track. So that's the first little thing we've got going on there, and that's not really anything unusual. I had that set up anyway. Let's see if I can get rid of my little drawing there, and that's how I would normally set up boost control on an engine like this. We'll just come down here to the other aspect of how that works. Let me just find this. So we've got our feed forward table here. So this is basically the open loop duty cycle for the wastegate control. So we've got our boost aims on the vertical axis, RPM on the horizontal axis, and this is just the duty cycle before closed loop control is started up. That will be sent out to the duty cycle, so to the wastegate solenoid, I should say. Just getting us as close to our boost targets as possible so that the closed loop system has as little work to do as possible. All right, so we've got another function here, which I'll just come down to, which is our driver boost limit. So if we come down here, our engine boost limit table, again, we'll full screen this. So this comes through from the multi-position switch that I've got on the dash. I'm only using, in this case, 4 positions. And basically this is a percentage of that maximum boost. So a number of 100 with our boost target, our boost switch at position 4 there. Basically that's giving us all of the boost we're asking for in that main boost table that we already looked at. And you can see as I change that position from 4 down to 3, 2 and 1 and then finally 0, we're reducing that boost target that we're requesting down. Now again, there's a limit here to what we can do, given that I can only get down to about 12 psi at 7,500 RPM. So we're limited to 402 wheel horsepower, which again I was expecting was going to be way too much. So another little trick we can do here, we'll come down to our initial setup 2, which is where we set up our drive-by-wire throttle table, and we've got our throttle pedal worksheet. We'll full screen this. So what we can do here, we've got the relationship between our throttle pedal position and the throttle actual throttle body or throttle plate position. So this is a single table here that we can see. I'll talk about how the other axis works in a second. So on the vertical axis, we've got the driver's pedal position, so what we're physically doing with our foot. On the horizontal axis, we've got our engine RPM, and the numbers inside of this table here, this is what we actually want the throttle butterfly to be doing. So if we look over to the right hand side, we can see that naturally we've got a bit of a curve here to this table. So it'd be very unusual that we'd want a one-to-one relationship between our throttle pedal position and our throttle body position. The reason for this is that the airflow through a throttle butterfly is very non-linear. What I mean by this is we get a large increase initially for a smaller opening in our throttle, and as we get past about 50, 60, 70% throttle, we don't see much of an increase or as much of an increase in airflow as we continue to open the throttle another 10%. So that's why we get that curve in there. It just gives us a slightly more linear relationship between driver's throttle pedal and our engine torque. However, the other trick that I'm doing here is that we can see that if we look at the 100% throttle row here, we can see that up to about 4,000 RPM, 100% driver pedal does ask for 100% throttle position, but you can see that particularly up at 6,000 and 7,000 RPM, I'm dropping that down all the way to 60%. So by tapering this back down, what it allows me to do is essentially close the throttle. This actually results in less boost in the intake manifold. We've got less airflow, and we can artificially tailor or taper shape our torque curve to suit. And if we come back across to the dyno screen here, that was the result with our yellow run there. We got it down to 372 horsepower by closing the throttle down to 60%. So what I did was just link the driver switch on the steering wheel so it functioned both the boost targets and my throttle map. We come back to the Motec M1 software. We can see here, basically I've got these tables along the fourth axis here, which is our driver throttle pedal translation switch, a bit of a mouthful. So that's on position 0, which you'll remember hopefully was asking for minimum boost pressure. pressure. As we go to position 1, we can see that those numbers in the higher RPM range start to bump up. We're now at 70% instead of 60%. We go to position 2, now we're at 80%, position 3, 90%, and position 4, we're asking for all of the throttle. So just a few little tricks that we've got at our disposal that are going to tame down the way the torque is delivered, and can make a twitchy, difficult to drive car, can really tame that down, particularly on a wet track. So how did everything go? Glad you asked. Let me just show you. If I can't find it, I can't. Bear with me for a second and I'll just, oh, there we go. Right, so I actually had a really good weekend of racing. I'll just show this little clip here. This is a dry race on the Sunday following this little EG Civic, and shouldn't be a fair fight, but it's actually a really fast car powered by a modified K20. And this was a bit of a moment, not something I was really looking forward to. This cut corner here requires a bit of commitment with a concrete wall on the outside, and the car spun right in front of me. And this is difficult because when I saw the back of the car break loose, I knew what was about to unfold in front of me, but at this point I'm already committed mid-corner. I've got a concrete wall on the outside of the car. Jumping on the brakes there probably wasn't going to work that well for me, so I rolled out of the throttle to bleed off as much speed as I could. At this point here I'm looking at the car and I'm basically waiting for it to grip up and hook right in front of me and basically come across the front of the car towards the pit wall. A little bit of a combination of good luck and a bit of good management by the driver in the EG Civic, and he actually managed to gather things up, get it straight. I dropped down a couple of gears and managed to get everything back under control. So quite thankful that that didn't go the way I was expecting. So anyway, we carried on. Basically in this race I'd actually started from the rear of the grid because I had a transponder issue the previous day, and basically I'd started from 17th position, and over the course of about 5 laps, there we go, I'll just try and managed to get myself from 17th position up to 5th. Car I'm chasing down at the moment is a LS7 7-litre V8 powered Super Tourer, Australian domestic market Ford Falcon. I was definitely faster than the car, but it's of course one thing to catch it, it's another thing to actually find a way past. So one of the things that's really nice with the 8.6 is it's exceptional under brakes. It's not too shabby in a straight line either, but really good under brakes, particularly much better than this Super Tourer, which is probably a much heavier car. So in this instance, managed to find a little way, ran a bit wide there into the hairpin, got up the inside of him, and basically managed to get my way past. So pretty happy with how everything went. So all up, we had 4 races. Actually ended up having 2 technical DNFs because of a transponder issue in one, which I just mentioned, and then in the 3rd race, the only mechanical issue we actually had, I broke the linkage between the gear lever and our TTI 6-speed sequential gearbox. Relatively minor. The boys ended up shooting back to the workshop, machining up a new one with a thicker wall, and had us back up and running for the 4th race, which again, because of the DNF, started from the back of the grid. So I had 2 races from the back of the grid. Not a great way to get points for the series, but really exciting and fun, passing a bunch of cars in pretty quick succession. So all things considered, the car excelled. Really didn't put a foot wrong. We're really stoked with the results. It's really fast, and we're really excited about the potential. One thing that is problematic here is that with the endurance racing, we had found issues with the cooling on the car, and realistically, with only doing 6-lap sprint races here, particularly in relatively cold weather, it was too difficult to really say whether or not we've improved that situation or whether we've fixed it. So we're going to be doing some testing privately in the not too distant future, and we'll go and actually run the car hard for an hour or so and see what actually happens there. That'll give us a better indication. Plus the crew are also in the midst of starting to get the aero package fitted to the car. We kind of wanted to fine-tune all of the other issues out of it before we worried about making more potential problems that we needed to deal with. So one thing at a time. Now, one of the issues we did highlight, and this is nothing new, I was trying to build some more bottom end response. The P12 cams were one of the aims that we were sort of hoping would improve that. It did. 50 odd horsepower in the mid-range is certainly nothing to be unhappy about. And I'd still like to bring that boost response further across to the left. So one of the things we are doing there, we are going to be swapping to a Garrett G25 660. So if we jump across to my laptop screen, It's a little hard to see, but a bit of a comparison for size. The turbo that's on the car at the moment is a GTX 3076 Gen 2. So not a slouch in terms of turbo technology, but the G25, particularly the turbine wheel, much smaller than the GTX 30. So we're hoping, and I mean, it's difficult to get really solid results here or solid answers out there because there's not a lot of people who have done comparisons. We're hoping that this should bring the boost in maybe around 500 RPM earlier without really sacrificing too much top end. We actually wanted to do this test right from the outset, which is why we went with the GTX 3076. So we're going to be documenting all of this with a YouTube video as well. The great thing is with this particular car, we've got a huge amount of data on board. We've got turbo speed, we've got exhaust manifold back pressure, we've got compressor inlet and outlet temperature and pressure, and this is going to allow us to really get some solid data about the performance of that GTX 3076 and compare it to the G25 660. While at the moment we've only run the thing to 15 psi on the dyno, we will be putting it back on with the GTX 3076, running up to maybe 22 or 24 psi, leaning on it a little bit harder, so we've got a couple of data points when we put that G25 turbo on it. So it'd be really interesting to see what we gain and maybe what we lose, if anything. The reason I'm not too worried about losing a little bit of top end power at the moment is that we're again really not leaning on it boost wise. If we want to make more power, it's going to be as simple as adding a little bit more boost. So we've got plenty of potential there. That 460 wheel horsepower, it's probably there or thereabouts the sort of region we will probably run it at in endurance trim anyway. The aim is to really get around the track as quickly as we can using as little power as possible, because we do need to run this car for an hour, or potentially if we step up to the 3 hour, there will be a little bit more running on track. So that's some things that we do need to keep in mind. So again, we'll keep you updated with how that all pans out. Right, I'll head back across to my notes for a second here. And I did mention our giveaway. We've got the Nexus R5, and while I said that I didn't have it here to show you, if we jump across to my laptop screen, the reason I don't have it here to show you is I don't need to. If you head to our YouTube channel, you'll find just recently in one of our latest videos, Zach, our ex-wiring tutor, who have managed to grab back in from time to time from his day job at the university, came in and filmed a complete unboxing on the Nexus R5. He goes into detail on exactly what is included, the features and benefits of that Nexus R5 ECU. So if you do want to learn about that ECU, maybe you've been hiding under a rock and you've never heard about it, check out that YouTube video when you get the opportunity. In terms of other things that have been going on, I did mention, or I have been mentioning for the last few webinars, that we are running a podcast, and our latest podcast, if we head across to HPA Tech Talk here, we are talking transmission tuning 101 using a Motec M1 standalone ECU as a controller. This is running a special package that is developed by Motec. So if you want to learn about that, you can check that out. And if you want to find our podcasts, they are available anywhere you listen to podcasts, but head to hpatechtalk.com to find out more. Lastly for today, Instagram that I put up last night, and I got a little bit of attention, a little bit of comments on that, and I wanted to just cover this off. So this is actually a little while ago. I shot this shot here at the Texas 2K event back in 2019. A little while ago now, and this is the Titan Motorsport Copper Supra drag car. What's interesting here is we've got what you can see quite clearly is a Tile Sport external wastegate, but it is fitted on the intake plumbing between the intercooler and the throttle body. Not the usual place we'd find a wastegate, given that they are normally used to control boost by bypassing exhaust gas around the turbine wheel. So we're normally going to find these on the exhaust manifold. However, these are quite commonplace on high-powered drag cars, particularly those that run a drag racing style slipper or slider clutches. They're referred to a centrifugal clutch that's adjustable. And the reason for this is that with a slider style clutch, it's critical for consistency that when the driver sidesteps the clutch on the start line, we want to make sure that, first of all, the boost pressure is always exactly the same. That means that if the boost pressure is the same, we're going to have the same engine power. The other part that goes hand in hand with that is that the engine RPM must also be absolutely rock solid. That'll affect not only the engine power, but also the centrifugal weights on the clutch affect the lockup, which is affected by engine RPM. Anyway, the boost pressure is what we're interested in here. So if we're controlling the boost pressure using an external wastegate as normal, what we're going to find is that on a two-step limiter that we use to get these large turbos spooled up on the start line, we're going to be using a lot of ignition retard coupled with an ignition cut that bypasses fuel and air into the exhaust manifold where it combusts. And what this does is it creates pressure spikes or pressure pulses, which help drive the turbocharger, which is why we can get just about any level of boost pressure we want while the car's stationary. But because of the turbulent nature of those those exhaust manifold pressure spikes, it tends to also create spikes in our boost pressure. So if we're looking at logging from our boost pressure, it's going to be oscillating up and down, even if it's only a PSI or so, depending whether the driver drops the clutch at a peak or a trough of that boost pressure oscillation will affect how the car leaves the line. So instead, using an external wastegate like this, basically when the driver is on the two-step, we can see that there is a little 3-port solenoid here. Boost pressure is supplied to the bottom side of the wastegate, and that will try and force the wastegate open against the spring pressure. So basically the boost pressure that the engine sees will be controlled or defined by the spring that is fitted to the wastegate. It's nice and smooth, it's really accurate, and you're going to end up with almost rock solid stable boost every time. You can go a little bit further and pulse width modulate that solenoid to get further control as well. Once the driver leaves the line, that 3-port solenoid closes, and basically the boost pressure is then supplied to the top port of the wastegate, which helps try and drive it closed. That coupled with the spring pressure means it's not going to leak. So not something you'll see everywhere, but if you're wondering why you see these external wastegates fitted on intercooler plumbing on drag cars, that is why. All right, just a reminder, the Haltech Nexus R5 plus our suite of tuning courses, 9 days left to get your name into the draw. It is a great prize, one of the more expensive prizes we've had the privilege to give away here. So thanks to Haltech for supplying that. We'll ship it to your door regardless whereabouts you are in the world. So don't miss out on that. Get your name into the draw. Again, you can follow the link that the team have dropped into the chat or the comments to get your entry in. All right, thanks for watching there. Give me a few moments. We'll get started with today's webinar.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.